So you've seen how you can reuse code in your program by defining functions once. What if you wanted to reuse a number of functions in other programs that you write? As you might have guessed, the answer is modules. In this video, we continue learning the fundamentals of the Python programming language, focusing our attention to modules and statements. Simply, a module is a file consisting of Python code. A module can define functions, classes, and variables. It can also include runnable code. For example, a module might look like this. As you see, a module looks pretty much like your normal Python program. There are various methods of writing modules, but the simplest way is to create a file with a .py extension that contains functions and variables. A module can be imported by another program to make use of its functionality. This is how we can use the Python standard library as well. First, let's see how to use the standard library modules. First, we'll import the sys module using the import statement. Basically, this translates to us telling Python that we want to use this module. The sys module contains functionality related to the Python interpreter and its environment, i.e. the system. When Python executes the import sys statement, it looks for the sys module. In this case, it is one of the built-in modules, and hence Python knows where to find it. If it was not a compiled module or a module written in Python, then the Python interpreter will search for it in the directories listed in its syspath variable. If the module is found, then the statements in the body of that module are run, and the module is made available for you to use. Note that the initialization is done only the first time that we import a module. The argv variable in this sys module is accessed using the dotted notation, i.e. sys.argv. It clearly indicates that this name is part of the sys module. Another advantage of this approach is that the name does not clash with any argv variable used in your program. This variable is just a list of strings. Specifically, it contains the list of command line arguments, i.e. the arguments passed to your program using the command line. If you're using an IDE to write and run these programs, look for a way to specify command line arguments to the program in the menus. So, do you wish you could get rid of the module name part that you have to put before every item you use from a module? You can import only the wanted objects from the module using Python's from statement. The from import has the following syntax. This statement does not import the entire math module into the current namespace. It just introduces the item's square root from the module into the global symbol table of the importing module. It's also possible to import all names from a module into the current namespace by using the from import star statement. This provides an easy way to import all the items from a module into the current namespace. However, this statement should be used sparingly. What's the point of this? Well, maybe you could use it to make your code a little more readable. If we get into heaps of modules and side modules, it could also remove that extra layer of crypticness. Every module has a name, and statements in a module can find out the name of their module. This is handy for the particular purpose of figuring out whether the module is being run standalone or being imported. As mentioned previously, when a module is imported for the first time, the code it contains gets executed. We can use this to make the module behave in different ways depending on whether it's being used by itself or being imported from another module. This can be achieved using the _name_ attribute of the module. Creating your own modules is easy. You've been doing it all along. This is because every Python program is also a module. You just have to make sure it has a .py extension. I'll switch over to Python Win to show you an example. Okay, so here we have a sample module where we are defining say hi and printing hi, this is my module speaking. and we are listing a version of 0.1. This module is saved as mymodule.py, and we'll see next how to use this module in our other Python programs. This module is saved to the same directory as the program from which we import it, or it can also be saved in one of the directories listed in the sys.path. So here we have another module, mymoduledemo.py, where we're importing mymodule, and we're printing the version, mymodule version. So let's run this module. Hi, this is my module speaking, version 0.1. The built-in dir function returns a list of names defined by an object. If the object is a module, this list includes functions, classes, and variables defined inside that module. This function can also accept arguments. If the argument is the name of the module, function returns lists of names from that specified module. If there's no argument, function returns list of names from the current module. First, we see the usage of dir on the imported sys module. We can see the huge list of attributes that it contains. Next, we use the dir function without passing parameters to it, and by default, it returns the list of attributes for the current module. Notice that the list of imported modules is also part of this list. By now, you must have started observing the hierarchy of organizing your programs. Variables usually go inside functions. Functions and global variables usually go inside modules. What if you wanted to organize modules? That's where packages come into the picture. Packages are just folders of modules with a special file type that indicates to Python that this folder is special because it contains Python modules. Let's say you wanted to create a package called World with sub-packages Asia, Africa, etc. And these sub-packages in turn contain modules like India, Madagascar, etc. This is how you would structure the folders. Packages are just a convenience to hierarchically organize modules. Just like functions are reusable parts of programs, modules are reusable. Packages are another hierarchy to organize the modules. The standard library that comes with Python is an example of such a set of packages and modules. We've seen how to use these modules and create our own. Next, we'll learn about some interesting concepts called data structures.